Welcome to qnawire.
Okay, to answer this question, we really just need the equation lambda, which is, your light wavelength, is equal to d, which is the slit separation, right, times y, which is the bright fringe separation, over the order of the bright spot, which in this case is 1 because you're looking at the distance between the central spot and the first bright spot, and L, which is the distance to the screen. So if we were to draw a little diagram of this, right, this is D, right? And that's what we were told was 1/1000th of a millimeter, or 0.001 millimeter. Okay. And then there's L, which is the distance to our screen, not to scale, obviously. And then there's going to be our brightest spot. Okay. And this is Y, the distance between the first brightest spot and the second brightest spot. And then M is like, if this is 0, the brightest spot, then the second brightest spot is 1, and then this is there, and then, okay, so like M is 1 minus 0, right? If we were to go from here, if we wanted to measure the distance between these, then we would have to do M equals 2 minus 1. Or if we wanted to measure the distance between like the third brightest spot and here, then M would equal 3 minus 0. And then Y would have to be this distance, right? That's not what we're doing here. I just wanted to point that out. Okay, so here M equals 1 because we're looking at the central spot and then the first bright spot. So we just have M equals 1. Okay, so we've got 0.001 millimeter. Okay, and we're told that Y between the center spot and the first bright spot was 99 millimeters, and that the length L was 154 millimeters. Okay, so let's see what we get when we plug this in. So 0.001 times 99 divided by 154, and I get 0.0000643. And right, this is millimeters. Okay, if we wanted nanometers, we would have to take this, and so millimeters equals 1 meter. 1 times 10 to the minus 3 meters. A nanometer is 1 times 10 to the minus 9 meters, right? So if we move this decimal point over 6 places, right, suddenly we have 643 nanometers.